playing with the homework a little bit. 5.4, number 11. There are videos that accompany this, and if you get stuck on it, message me with that problem with the message link attached to the problem. So let's see, what do we got? We have the sine of -3/7, and theta is in quadrant 3. So most important thing here is we draw a picture. So let's lay out X and Y axes and draw our best circle. Try that again. All right, maybe I'll start here and go around. That's a little bit better. All right, so things to know to make this happen. I like to work with the unit circle, simplifies things, radius 1, makes things a little nicer in my opinion. Sine is a y value. So on the circle, I'm looking for y equals -3/7. So over here is, y is -1, that would be down here. X equals -1. 3/7 is a little less than half, so that's probably around right here. And for y value, right, that means and let's reposition that. I missed just a little bit. All right. So here is a line matching on the circle where y is equal to -3/7. So that leads to either this point here or leads to that point here. And so then they tell me, hey, look at quadrant 3. All right, so that means I want that point right there. And then I want that as my radius. And that means theta must be this angle right here. Okay, so here's my picture of sine of theta equals -3/7 in quadrant 3. And then based on that, I want to figure out what's the cosine, what's the tangent, what's the secant, and so on. So reminder about quadrant 3 here, the y value is negative and the x value is negative in there, right? So I have negative coordinates for both when I find these. The cosine is whatever the x value is there. So we'll have to find that. The tangent will be y over x. The secant is going to be the reciprocal of the cosine. So that's just going to be 1 over x because I'm saying the cosine is x. Cosecant's reciprocal of the sine. Well, I can get that right away. Sine is the y value, so it's just 1 over y. And the cotangent is the reciprocal of the tangent, so that's going to be x over y. So it looks like we just need to find x, and then we can name all of these. So let's go find x. How do we find x here? Well, Pythagorean theorem is the key to do that, whether you look at it as the Pythagorean theorem in trig form or in standard form. So the x value is somewhere over here, right? Pretty close to -1, and that's going to give me a right triangle there. And so if I just kind of redraw that right triangle over here, I know that this, I'm just going to call it +3/7 now because I am sine aware there because I'm in quadrant 3. I need to figure out what x is. I'm on the unit circle, so the radius is 1. So this tells me that x squared plus my 3/7 squared equals 1 squared or 1. 3/7 squared would be 9/49 on a good day. Subtract the 9/49 over. So 1 minus 9/49. 1 would be 49/49. 49 minus 9 is 40. So x squared is 40. That's a 4 divided by 49. Taking the square root, I get x is plus or minus square root of 40 over 49. And I recognize, again, 49 is a perfect square, so I can rewrite this as the square root of 40 over the square root of 49, which I can then say is plus or minus square root of 40 over 7. All right, so then I got to think, do I want the plus or the minus? Well, according to my picture, I'm looking for a negative x value, so I want not the plus, but the minus, negative square root of 40 over 7 is what I want. And then it's just a matter of plugging into what I know they mean about the basics of trigonometry we talked about earlier. So the x value is the opposite of the square root of 40 divided by 7. Y over x, I'm going to write that to the side because I can probably clean that up a little bit, which is the tangent of theta. So in this case, my y is negative square root of 40 over 7. X is negative 3 over 7. And what happens here is a negative divided by a negative is a positive. And then I have divide by 7 here, divide by 7 there. Those are going to cancel out. So I get positive square root of 40 over 3. And does it make sense that this line, that radius right there, has a positive slope? And the answer is yeah, right? Remember, tangent turns angles into slope. And I do see a positive slope on that radius. So that's a good sign. Secant, we flip the x value. So that would be negative 7 over the square root of 40. And I don't really care about rationalizing the denominator unless somebody told me to. So I'm not gonna. Cosecant, that means flip the sign 1 over y. So that'd be negative 7/3. And the cotangent is to flip the tangent. So that would be 3 over the square root of 40. Okay. How could we double check any of that? Well, that's a little trickier to check. I have my picture and I can double check the signs of things. I could graph this in a program that graphs these. That would be a way to check. Why don't we try that? So I'm pretty sure my answers are right there. And now I know in these problems, you do have the ability to hit submit and it will check for you, right? But on a test, you need to know it's right before you submit the question, right? And eventually you're gonna have to take a test in this class. So you gotta think, all right, I can plug them in and I can have the computer tell me if I'm right or wrong, or I can confirm for myself. So I'm going to use Geogebra to do this. And could I use this in Desmos too? Yeah, Desmos will do this too. But I like Geogebra. Gee, if I could spell it. And sure, let's go to Geogebra Classic. I usually use the geometry version in class, but this one's fine too. All right, so how do I do this? Well, I should draw the unit circle that I was playing with. So x raised to the second power plus y raised to the second power equals 1. So there's my unit circle, and I think I'll zoom in on that. Let's see, can I make this box go away? Whoa, that's not what I wanted. Go away box. Is there an X on here for this? You're in my way. That's annoying. Why did they do that to me? Oh, there we go. All right, so then let's zoom in a little bit. They called it equation 1, that's okay. And then I had to realize that the sign is the y value. So then on my picture, I graphed y equals negative 3 over 7. And so there's that down there. And then that led to this point right here. So point button, I want to find the intersection. And so I just click there once I choose intersection. And it tells me I get negative 0.9-ish and negative 0.343. And so the negative 0.43, right, that's my y value, negative 3/7 is 2 decimal places. And this one right there should be that square root of 40 over 7, but negative. So let's just check. Negative square root of 40. Get outside the root with the arrow and then divide by 7. And there is that 0.9. Is it exactly 0.9? The answer is no. So let's see, somewhere here I can ask for more decimal places. Let's zoom out of the way. Here, and let's go grab, I don't know, 10 decimal places for fun. All right, so I can see that those decimal places do match there. And we could do the same thing in Desmos. So let's try it there for you Desmos users out there. Desmos graphing calculator, this one. So pretty similar, x squared plus y squared equals 1. Zoom in. Oop, too far. And then y, we have to know that the sign is the y value, is negative 3/7. And then we want to know what is that value right there. And Desmos, I know, yeah, Desmos, can I get it to show more decimal places? Don't see the option there or there. But I can point to it and get it. So in some ways, Desmos is easier to use because I didn't have to find that intersection. It found it for me. On the other hand, it's not showing me many decimal places, and I don't seem to be able to control that on the screen. Maybe there is a way and I'm just missing it. And then again, I can confirm that y value of that point by just typing what I calculated, which was the square root of 40. Get out of the root, then divide by 7. Order of operations is very important. And if we were to round that to 3 decimal places, we would get 0.904, which is what they told me over here. All right. Can I easily check the other trig functions? The answer is not yet. So then I have to just rely on, did I do a good job in how to get the tangent, how to get the secant, how to get the cosecant, how to get the tangent. So, but I could confirm that I have the right x value on either program.